You know that feeling when you're trying to find, like, a needle in a haystack? Or maybe a better way to put it is having this incredibly smart assistant, brilliant generally,
Hmm.
but ask them something super specific from your world, like company documents,
Mm.
niche research.
Yeah, they just give you that blank stare. It's that gap, isn't it, between
Yeah.
the huge general knowledge
Mhm.
LLMs have and the crucial specific context you need.
Exactly. For those real-world specialized tasks, LLMs are amazing, but getting reliable answers from your own data is still tricky.
It really is.
And that's precisely the challenge we're digging into today. We've got some great source material here, excerpts from an IBM technology video looking at a really interesting technique for this.
Right. So our mission for this deep dive is basically to unpack this thing called Retrieval-Augmented Fine-Tuning, RAFT for short.
RAFT. Got
We
it.
want to figure out how it works and, how it promises to make LLMs better, more reliable in those specific areas you care about.
Okay. And to really get why RAFT is interesting, it helps to see what else is out there first, right? Our source contrasts it with the two more common approaches.
Yeah, standard retrieval, augmented generation, RAG, and then traditional fine-tuning.
So let's quickly lay those out first. Set the stage. Where do we start? ARGI.
Yeah, let's do RAG. So think about RAG happening during inference. That's basically just when you're actually asking the model a question, trying to get an answer.
Okay, so I asked my question.
Right, and before it even hits the main LLM, this other bit, the retriever, goes off and searches some database. Could be a vector database, whatever.
Looking for documents it thinks are relevant to my question.
Exactly, and then those docs it finds, they get bundled up and stuffed right into the prompt that goes to the LLM.
So the model sees my question plus all this extra context material.
Hmm.
Our source uses a great analogy for this. It's like taking an open book exam,
Yeah.
but one you didn't study for at all. You've got the book, the answers are in there.
But whether you pass or fail, it really depends on how good you are right then at finding that exact piece of info you need. Quickly.
Right, which really highlights the core dependency of RAGs, doesn't it?
Totally. The model's performance hangs completely on how well that retriever does its job. Did it pull the right stuff?
Because if it pulls irrelevant documents or maybe misses the key one,
Then the model might just, struggle or go off topic or even worse, confidently make something up, hallucinate.
okay, so RAG, a real-time context, but super dependent on that retriever search. Got it. How's fine-tuning different then?
Well, fine-tuning is happening way earlier.
Yeah.
It's part of the training process.
Oh, okay.
You take a pre-trained LLM, one that already knows a lot about language in the world.
And you train it more, but on data specific to your area, like, say, feeding it tons of internal company reports.
Precisely. Or medical journals if you're in healthcare, yeah. And the knowledge from that specific data set gets, well, the source says, baked right into the model's parameters.
So you're actually changing the model itself.
You are.
And the analogy for this one is like studying really hard for a closed book exam.
You cram everything in beforehand.
But come exam day, if there's a question on something that wasn't in your notes, or maybe something new came up yesterday.
You're stuck. You can only rely on what you memorized, what's baked in. It can't easily grab new info.
Right. So if your fine-tuning data wasn't complete or it gets outdated, the model just hits a ceiling.
Exactly. Performance suffers.
Okay, so we have our real-time context, relies on the retriever. Fine-tuning baked-in knowledge, but static, limited by training data. Both have these limitations, especially when you need something really reliable and knowledgeable for a very specific, maybe changing domain.
And that is the sweet spot RAFT is aiming for. Retrieval-Augmented Fine-Tuning.
The hybrid approach, trying to get the best of both.
That's the idea. And it came out of UC Berkeley research, which is pretty solid grounding.
Okay, so what's the core concept? How does it combine them?
Well, it's actually quite clever. Instead of RAG just giving the model context when you ask a question.
At inference time.
Right. Or fine-tuning just baking in facts during training. RAFT does something different. It teaches the model how to use RA, but it does this during the training phase itself.
Ah, okay, wait. So it's not just giving it info, it's teaching it a skill, the skill of using external info.
You got it.
So back to the exam analogy. RAFT is like an open book exam.
But this time, you did study.
Right. So you have the background knowledge,
Yeah.
and you know how to use the book effectively.
Exactly. You know how to navigate those resources. The source also uses the teach a man to fish idea.
Oh, I like that.
Yeah, instead of just handing the model a fish like the answer or the right document, RAFT teaches it how to fish, how to look for documents, figure out which ones are good, and use them to build the answer.
Okay, that makes a lot of sense. So if it's a training technique, the training data must be pretty special. How is it structured?
Absolutely key. The source explains that each data point for RAFT training has three parts. There's the query,
The question.
yep, then a set of documents, and finally the correct answer, which should be derivable from those documents.
And these documents, they're not all relevant, are they? I remember the IBM parental leave example.
Good memory. No, they're not all relevant. You have two types. First, core documents. These actually have the info needed to answer the query.
Like the paid leave policy for the IBM question.
Right, or benefit eligibility details. Then you also have tangent documents.
The relevant stuff.
Exactly, deliberately off topic. Like for the IBM example, maybe docs about retirement plans or internal coding standards, stuff that might be in the database, but useless for this question.
Okay, core docs, tangent docs, got it. But then there was something clever about how these were grouped into sets for training.
Yes. This is really interesting. There are two types of document sets used in the training data.
Okay.
Set type 1 contains both core documents and tangent documents for a given query.
All right, that seems logical. It simulates a real RJ search, where you get back a mix of useful and maybe not so useful results.
Right. But the second type of set, this is the clever bit, it contains only tangent documents.
Wait, just the irrelevant stuff? No core documents at all?
None. For that specific query example in the training data, the answer isn't actually in the documents provided in that set.
Huh. Why? Why would you do that? What's the point of training it on data where the answer isn't even there?
Well, think about real-world R again. Sometimes the retriever just fails.
Yeah.
Right? It searches, but finds nothing genuinely relevant to your specific query.
Okay. Yeah, that definitely happens.
So by training the model on these sets with early irrelevant tangent documents, you're teaching it what to do in that exact situation.
Ah, you're teaching it not to just make something up.
Precisely. Not to hallucinate, not to try and force an answer out of junk documents. It learns to maybe fall back on its general knowledge, or even better.
To say, I don't know, or the answer isn't here.
Exactly. It learns to signal that the provided context isn't helpful.
Wow. Okay, that's actually really smart. It's like building in a kind of epistemic humility, knowing when you don't know based on the evidence given.
That's a great way to put it. And the way it learns to find the answer when the core docs are present is also specific. They use chain of thought reasoning during training.
Chain of thought. So spelling out the steps.
Sort of, yeah. It guides the model step by step. Look through these docs, filter out the noise from the tangent ones, zero in on the core ones, and then reason through the information in those core documents to construct the final answer.
So it's learning the reasoning process itself. And this is all done via devised fine-tuning, just with this very specific data structure and reasoning guidance.
That's the gist of it. And the source mentions the framework is adaptable. You can plug it into various base LLMs. The goal is a model that's really robust for these domain-specific tasks.
Okay, let's boil this down then. What are the really critical takeaways from this whole RAFT training process? Why does it matter for you listening, trying to get reliable answers on your own data?
The source highlights three key things. First, what we just talked about, handling irrelevance.
Dealing with the noise.
Exactly. Because it trains with tangent documents, the model gets much better at ignoring useless information and focusing only on what's actually relevant in the context it's given. That directly boosts accuracy, especially with messy real-world data.
Makes sense. Gets better at filtering. What's number 2?
Knowing when to stop. That comes from training on those sets with only tangent documents.
Right, the I don't know capability.
It teaches the model that if the answer isn't in a provided context, don't invent one. Just say so, or rely on general knowledge if appropriate. This is huge for fighting hallucinations, which is critical for trust.
Absolutely critical. If you need factual answers, you can't have the model just making things up when it gets stuck. Okay, and the third point.
Transparency and accuracy, which is helped by using that chain of thought approach during training.
How so?
Well, by guiding the model to derive the answer logically from the source docs, it discourages it from just memorizing answers, overfitting. And practically speaking, it often means the model can better cite its sources, like point to the specific sentence in the document it used.
Ah, traceability. So you can actually see why it gave the answer it did, check its work.
Exactly. Builds trust and allows for verification.
So the end result of all this RAFT training, what is it?
It's a model that's designed to be both highly scalable and really robust for these enterprise or domain-specific jobs. For you, the listener, it means getting much closer to an LLM that can confidently, reliably, accurately answer questions using your specific information sources.
Helping you get those insights faster without drowning in irrelevant stuff or worrying about fabricated answers.
That's the promise. RAFT is really pushing LLMs beyond just being general knowledge engines.
Yeah, it's turning them more into skilled research assistants almost. Ones that know how to find and use external information effectively when needed.
It's about teaching them how to learn and synthesize in context, not just what facts to store.
Empowering them to genuinely augment your specific knowledge work.
Precisely. Making them much more practical tools for digging deep in your field.
Okay, so building on that, this idea of teaching models not just facts, but the process of finding information, checking it, and crucially, knowing when to admit uncertainty. What if we zoom out for a second? Consider this. What does it mean for the future of AI if we get really good at this? Training models not just on what's true, but on how to determine truth from evidence and how to handle ambiguity or lack of evidence. How might teaching models this kind of intellectual responsibility change how we interact with them, how we trust them down the line?